In this episode, we shift from talking about individual privacy risks to something bigger and more realistic in organizations. The privacy program that is supposed to keep those risks under control as AI systems grow and change. A lot of new learners picture privacy as a single policy document that sits in a folder and gets pulled out when someone asks for it. In practice, a privacy program is a living set of decisions, routines, checks, and accountability that should shape how data is collected, how models are trained, how outputs are used, and how problems are handled when they show up. The reason practical tests matter is that programs can look perfect on paper while failing in day-to-day behavior, especially when teams are under pressure to ship features quickly. You are going to learn how to evaluate whether the privacy program works by looking for concrete signals, not polished words. The focus is on simple tests you can apply even if you are new to cybersecurity and new to AI. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A useful mental model is to treat the privacy program like the brakes on a car rather than the paint on the hood. If the brakes are healthy, they work consistently, they work under stress, and they are checked regularly, not only after an accident. If the brakes are just decorative, the car looks fine until the moment you need it to stop quickly. When you evaluate an AI privacy program, you are asking whether the organization can reliably slow down risky behavior, redirect it, and prevent it from becoming harm. That means you care about decision points, because privacy protections only matter if they influence choices before data is used and before systems are deployed. It also means you care about consistency across teams, because privacy failures often happen when one group follows the rules and another group quietly does not. A practical evaluator looks for repeatable controls, not heroic one-off efforts. The first practical test is scope clarity, meaning whether the organization can clearly describe what the privacy program covers when it comes to AI. Many organizations have a general privacy program for apps and websites, but AI introduces new pathways like training data reuse, model outputs that reveal information, and third-party model services that process data. A program that never mentions training, fine-tuning, prompt logs, or model monitoring is often a program that has not adapted to reality. You can test scope clarity by asking how the program treats different AI use cases, such as internal analytics models, customer-facing assistants, and automated decision support tools. If the answer is one-size-fits-all, that suggests the program does not recognize that privacy risk changes dramatically with audience, sensitivity, and impact. Clarity also includes who owns decisions when AI is involved, because privacy gaps appear when everyone assumes someone else is responsible. The second practical test is intake discipline, which is the process for bringing a new AI idea into the privacy program early rather than late. If privacy only shows up near launch, teams tend to treat it as a blocker and try to argue around it. A healthier program has a standard intake path where an AI project is described in plain language, the data sources are identified, and the intended outcomes are documented before development gets far. Many organizations use something like a data protection impact assessment, DPIA, or a similar risk assessment to force this early clarity. What matters for your evaluation is not the name of the form, but whether the process exists, is used routinely, and produces decisions that teams actually follow. A practical sign of strength is that teams can explain when an assessment is required and can show examples of projects being changed because of the assessment. If no one can recall a case where privacy review altered the plan, the intake process may be a ritual rather than a control. The third practical test is data mapping that is specific to AI, because AI privacy risk depends on how data moves through training and operation. Traditional privacy mapping often focuses on collection and storage, but AI adds steps like labeling, transformation, training, evaluation, prompt handling, and output retention. A solid program can tell you where training data comes from, where it is stored, who can access it, and how it is separated from unrelated datasets. It can also tell you whether user prompts and model outputs are stored, for how long, and for what purpose, because prompt logs can become a new collection of personal information very quickly. Your practical test is to ask for a simple end-to-end story of the data pipeline, including what leaves the organization when vendors are involved. If the story has blank spots, that is often where privacy risk is hiding. The fourth practical test is minimization in action, meaning the organization has a habit of limiting personal data to what is necessary and can prove it with examples. Minimization sounds like a principle, but you can evaluate it as a behavior by looking for evidence that teams remove fields, shorten retention periods, or avoid sensitive sources when they are not needed. A weak program treats minimization as a statement like we only collect what we need, while a strong program treats it as a default posture that must be justified if someone wants more data. You can test this by asking how the organization decides whether to include free text notes, images, voice recordings, or third-party enrichment data in an AI pipeline. When teams say they want more data because it might improve accuracy, the privacy program should require a clear trade-off analysis and safer alternatives. If you never see the program pushing back on data expansion, it likely is not controlling risk. The fifth practical test is purpose discipline, which asks whether data collected for one reason is prevented from being quietly reused for another. AI projects often tempt organizations into reuse because old datasets are convenient and large. The privacy program should enforce purpose limits by requiring that teams connect data used to a clear, approved purpose and evaluate whether a new purpose is compatible with the original context. This is especially important with customer interactions, employee data, and student data, where people may feel betrayed if their information is repurposed into monitoring or scoring. You can test purpose discipline by asking how the organization handles requests like using support chats to train a model, using call recordings to analyze emotion, or using employee communications to detect risk. A strong program can explain when those uses are not allowed, when they require extra approvals, and what safeguards are required. A weak program answers with vague confidence and no clear boundaries. The sixth practical test is consent and notice quality, because privacy is not only about internal control, but also about honesty with people. If the organization relies on consent, it needs to be meaningful, understandable, and tied to the specific use, not bundled into general language that people cannot realistically interpret. If the organization relies on legitimate interest or contractual necessity in some legal frameworks, it still needs clear notice so people are not surprised. With AI, notice needs to cover things like whether interactions may be used to improve models, whether outputs are logged, and whether automated processing influences decisions. A practical evaluation asks whether the organization can show what users are told, when they are told, and how they can make choices or opt out where appropriate. If the organization cannot explain notice in plain language, it is unlikely that the people affected truly understand what is happening. That gap between what is done and what is understood is a common root cause of privacy harm. The seventh practical test is rights handling, which becomes more complex when AI is involved. People may have the right to access their data, correct it, delete it, or object to certain processing depending on the context and rules that apply. In many programs, these requests flow through processes often called Data Subject Access Request, DSAR, handling. With AI, you have to ask what happens when a person's data is inside a training dataset, inside prompt logs, or influencing model behavior. A strong program has a defined approach for locating relevant data, applying retention limits, and being honest about what can and cannot be removed from existing models. The practical test is whether the organization has thought through how rights requests interact with training and model updates, rather than treating AI as a special case that escapes normal accountability. If the program says it honors deletion but cannot explain how it addresses model influence, that is a misalignment worth flagging. The eighth practical test is vendor governance, because many organizations rely on external model providers, hosted platforms, or labeling services. Vendor involvement changes privacy risk because data may leave the organization, may be stored in different regions, or may be used for vendor improvement unless restricted. A strong privacy program does not treat vendors as magic boxes. It requires clear terms about data use, retention, access controls, and security measures. It also requires the organization to know what the vendor is doing with prompts and outputs, especially if those interactions include personal information. A practical evaluation looks for consistent vendor review steps, clear contractual restrictions, and an understanding of what data is shared for what purpose. If teams can onboard a vendor quickly without privacy review because the vendor is popular, that is a signal that governance is being bypassed. Privacy programs often fail at the vendor boundary because convenience wins unless controls are firm. The ninth practical test is incident readiness for privacy, which means the organization has a plan for when privacy goes wrong in an AI context. Privacy incidents in AI can include accidental exposure through outputs, misrouted data in training pipelines, unauthorized access to prompt logs, or a model being used to infer sensitive traits. A good program has clear reporting paths, triage steps, and response roles that include privacy expertise, not only technical security. It also has a habit of learning from near misses, because waiting for a major incident is too late. Your practical test is to ask for examples of issues found and fixed, even small ones, and what changed afterward. If the organization only talks about incidents as theoretical, it may not have exercised the process, and untested processes often fail under stress. A program that is prepared can describe its playbook in a way that feels practiced and real. The 10th practical test is monitoring and change control, because AI systems evolve, and privacy risk can appear later even if the initial launch looked clean. Models get retrained, new data sources are added, prompts change, and use cases expand into higher-stakes decisions. A strong privacy program ties privacy review to change events, so that adding a new dataset or expanding access triggers assessment, not just a technical ticket. Monitoring also includes watching for misuse patterns, such as users pasting sensitive records into prompts or using the model to look up information about individuals. Practical evaluation asks whether the organization logs meaningful activity, reviews it, and acts on it, rather than collecting logs that nobody reads. If a team says privacy risk is addressed by policy alone, but there is no monitoring to detect violations, the program is relying on perfect human behavior, which is not realistic. A mature program assumes mistakes will happen and builds detection and response around that assumption. The 11th practical test is accountability, which is the difference between everyone caring about privacy and someone being responsible for it. Accountability means clear roles, clear authority, and clear escalation paths when privacy concerns conflict with business goals. With AI, this often includes decisions about whether a use case is allowed, what data sources are approved, what safeguards are required, and when to stop deployment. A strong program has a governance body or responsible owners who can make these calls and who keep records of decisions. It also provides training and guidance so teams do not accidentally violate privacy because they are confused. Your practical test is to ask who can say no and whether that person or group has actually said no before. If nobody has that power, or if the power exists only in theory, privacy becomes a suggestion rather than a control. To wrap up, evaluating an organization's AI privacy program with practical tests is about checking whether privacy is embedded in how work gets done, not just how documents are written. You test scope by seeing whether the program understands AI realities like training pipelines and prompt logs. You test intake by looking for early review habits that change projects, not just approve them. You test data mapping, minimization, purpose limits, consent or notice, and rights handling by asking for real evidence and clear stories that connect decisions to actions. You test vendor controls, incident readiness, monitoring, and accountability because those are the places where strong intentions often collapse under pressure. When you learn to evaluate privacy programs this way, you become effective at spotting gaps without needing advanced math or deep engineering knowledge. You also help ensure that AI systems earn trust through consistent behavior, which is the only kind of trust that lasts.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.